Okay, welcome back. Now we are going to talk about rational exponents, which are very closely related to radicals. If you have some expression like this, x to the b power, and then we're taking the 8th root of it, this is really x raised to the power a over b. A rational exponent, that's just a fraction. Rational numbers, remember, are fractions. So we're going to evaluate numbers raised to a rational exponent. We're going to go back and forth from the radical sign to the exponent sign form, exponential form, and vice versa. Then we need to simplify algebraic expressions. That's just using variables, and multiply and divide. So from last time, we learned this, that the square root of 5 is simply the number that when you multiply it by itself gives you 5. So what we want to do is write all these expressions in terms of radicals. So that first one says 5 to the 1/2 power inside the square root, that's 5 to the 1/2, and then what we're doing is squaring it. And we know this property, that when we have a power raised to a power, we simply multiply the powers. Well, what is 1/2 times 2? That equals 1, which is 5. And to me, this is easier to see over here than it is over here. This is clear. It's just the rules of exponents now. So let's look at the next one. What does it look like? I have the cube root of 8, which is 8 raised to the 1/3 power. And then, well, actually, since it's a positive number, I can write it like this. Maybe you'll like this better. 8 to the 1/3 power. And then what are we doing to it? We're cubing it. So our rule says multiply the exponents. What's 1/3 times 3? That's just 1. So that equals 8. Okay, we got one more to do. This one. I have 21 to the 1/4 power raised to the 4th power, and of course, that's 21. So this is the property we're learning here. Property tells me that if I'm looking at the nth root of some number, this can be written as in exponential form as that number raised to the 1 over n power. So that's very useful. Here's some more examples going the other way. 25 to the 1/2 power, well, that's the square root of 25, which we know is 5. 16 to the 1/4 power, that's the 4th root of 16. 8 to the 1/3 power, the cube root, and so on. Now this one, 36 over 49 to the 1/2 power. Well, we know we can do this. This is how exponents work with the quotient. And usually it's easier for us in our minds to write this with the radical sign because I don't think about the 36 to the 1/2 power very often, but I think about the square root of 36, and that, of course, is 6, and the square root of 49 is 7. Here we have negative 27 to the 1/3 power, And it's easier to evaluate if we go back to the radical sign and realize that we're just asking for the cube root of negative 27. So keep in mind, sometimes the radical form will be easier to evaluate because we're just more familiar with it. But a lot of times we're going to be using the exponential form. Okay, so here is the big idea. If we have, which I've mentioned before, the nth root of some real number raised to the m power, this is b to the m over n power. And it also can be written as the nth root of b raised to the m power. Why is that? Because that would be b to the 1 over n to the m power, which, when we get rid of the parentheses, is b to the m over n. And it really is important for you to understand this relationship. It will make your life so much easier. Okay, so yes, this is just talking about which form do we use. Well, it depends on the problem. So if you see 8 to the 2/3 power, I immediately say, okay, look, I know that this is the cube root of 8 squared. That's what they did here. Because we can, what's going on here? Well, we're writing this as 8 to the 1/3 power squared. We're allowed to do that because 2 1/3 times 2 equals 2/3. So this is easier for me to do because now I know that's in the parentheses, that's 2 squared, which gives me 4. However, you could have written it the other way because this is also equal to 8 squared to the 1/3 power because 2 times 1/3 is 2/3, right? So if we did it that way, we would be looking at the cube root of 64, which I happen to know is 4, but you might have to use your calculator for that. And these are some more examples. Suppose you want to evaluate 27 to the 2/3 power. Well, I don't know what 27 squared is. So I'm going to write this as 27 to the 1/3 power squared because I happen to remember what the cube root of 27 is. That's 3. But if you did it this way, then the other way, which would be 27 squared to the 1/3 power. So that means the cube root of 27 squared, which is the cube root of 729. You get the same answer. But to me, this is easier. All right, let's see if we can do these. 25 to the 3/2 power. So remember, the one in the denominator is the root. That's the root. So I know the square root of 25, so I'm going to say 25 to the 1/2 power cubed. In other words, the square root of 25 cubed. What's the square root of 25? That's 5. What's 5 cubed? 125. And of course, we don't put a 2 in here when we have a square root. This is understood. When there is no number there, that's the square root. Okay, let's try B. 16 to the 3/4 power. Well, I sure don't want to. This is the power on top. I don't want to cube this number. This is the root on bottom. So let's write this as 16 to the 1/4 power cubed. Well, what is 16 to the 1/4 power? You might have to think about it for a minute, but that's simply 2. What's 2 cubed? That's 2 times 2 times 2, which is the number 8. Now, here's a tricky one. 32 to the negative 5/2 power. Well, Dr. Maxwell says, why don't we change that to a positive exponent so it's easier for us to handle? This is a negative exponent. We can change it to a positive exponent by changing its position relative to the divides bar. Technically here it's in the numerator. If I put it in the denominator, it becomes positive. Now, I have 1 over, I don't want to square 32, but you could. I'm going to write this as 32 to the 1/5 power squared. And I know that 32 to the 1/5 power, this is the 5th root of 32. Isn't that 2? Think about it. 2 cubed equals 8. 2 to the 4th power equals 16. 2 to the 5th power equals 32. So I'm looking at 1 over 2 squared. So this number turns out to be 1/4. So for me, the key was get rid of that negative exponent right away. Put it in the denominator so it's a positive exponent and it makes life easier. Okay, here's a few more. Now, we're just talking about a negative number, the 3rd root, so that's okay. It can be negative because it's an odd root. So we're looking at negative 64 to the 1/3 power squared. So this is the cube root of negative 64 squared. So how do you solve this? Well, the cube root of 64, you may remember, is 4, because 4 times 4 equals 16. 4 cubed is 16 times 4, which is 64. So this is negative 64, so this is negative 3 squared. What's that going to be? Positive 9. Tricky, huh? All right, let's talk about tricky. This one is tricky. What do we do first? We do exponents before multiplication. So this is negative 1 times 8 to the 1/3 power, which means it's negative 1 times the cube root of 8, which is negative 1 times 2, which is negative 2. You see the difference there? We had parentheses here. We did not have parentheses in part E. Now, we're just going to use variables instead of numbers, and we're just going to write it in radical form. So this would be the fourth root of x cubed. That's the simplest way to write it. Technically, it's also the fourth root of x cubed. Now, is this 3 being raised to a power? No. So the 3 is outside of this radical sign. The root is in the denominator. The power is in the numerator. This is y squared. Okay? Let's try some more. Ay, ay, ay. Now, we might start by doing this. This is the fourth root of x times the fourth root of y raised to what power? Cubed. Now, we can do more than that. Because these have the same root, we can combine them. This is the fourth root of xy cubed. Now, how can I convince you that that's so? Well, isn't this the same thing as xy cubed raised to the 1/4 power? Because if we apply our rule for dealing with a product raised to a power, we just both terms get this. So sometimes it's easier for me to know what I'm doing is legal if I write it like this first. Now, this is a little different. What goes inside the radical sign is the cube root of this expression squared, isn't it? So how can I convince you that's right? Well, I could write this as x plus y squared to the 1/3 power, couldn't I? All right. Now we go the other way. What would this be? First, you might start by writing it as xy to the 1/2 power. But we want to go a little further than that. We are going to write it as x to the 1/2 times y to the 1/2 power. Now, let's see. This is a cubed times b to the 1/4 power. Do you agree? Now get rid of your parentheses. So this would be a to the 3 times 1/4, which is 3/4, b to the 1/4 power. All right, so let's see. The 4 is not inside here, so I'm going to just put it outside my parentheses. And I'm going to write this as x squared to the 1/3 power. And then I say, oh, of course, this will be 4x to the 2/3 power, right? This is the power that goes in the top. This is the root that goes in the bottom of our fraction. And this one is the fifth root of this expression. That might be your first thought, but then we realize we want to do something better than that. This is x plus y to the 4/5 power. Of course, you can skip this middle step if you don't need it. Now, let's see. Simplify each of the following. only use positive exponents. All right, the way I approach these is I put the things that I can combine together first. I know I can multiply 3 times 4, and I can multiply x to the 1/2 power times x to the 2/3 power. 1/2 and 2/3, right? So what is this? 12x. And what do we do in this situation? We add the exponents. So we need to do a little scratch work down here. 1/2 plus 2/3. Least common denominator is 6. So I multiply this one by 3/3, this one by 2/2, to see that I'm looking at 3/6, which is the same thing as 1/2, plus 4/6, which is the same thing as 2/3. So this is 7/6. So my final answer is going to be 12x to the 7/6 power. Okay. Now, you have a choice here. You could square everything. Well, I guess we have to, because look, we can't combine anything. Everything is different. We do not have a common base. So here we had a common base. That's why I could multiply these together. So this will equal 5 squared times a to the 1/3 squared times b to the 1/2 squared, which I think you can see is 25a to the 2/3 b, because 2 times 1/2 is 1. And we just don't put a 1 there because it's understood. So now we have some division. What I like to do is kind of separate things according to what I can combine. You see how I did that? It's perfectly legal. This and 12 divided by 6 is 2. How do I handle the y? Well, I use my rule. If you have y to the a over y to the b, this is y to the a minus b. So I have 1/3 minus 1/2. So again, I'm going to have to do a little scratch work. 1/3 minus 1/2. Common denominator, again, is 6. So 1/3 we need to multiply by 2/2, and this is 3/3. So we see that we have again, now, 1/3 is the same thing as 2/6, and we're subtracting off 3/6. So what do we get? 2y to the negative 1/6. However, positive exponents only. So how do I deal with that problem? I write it like this. To change the sign of the exponent, we put it in the denominator. Okay, last one. This, oh gosh, what do we want to do first? Well, I think we're just going to give everybody the exponent of 4. That's how this rule works. This 4 is applied to every single term in there. 3 to the 4th power is 81. X, well, now we're multiplying 2/5 times 4, so that will be 8/5. 2 to the 4th power is 16, and we have y to the 8/3. So it's just remembering how we deal with a quotient raised to a power. If you have a over b, let's say ac over bd to some power, it gets applied to every single term. Okay, so the rest of the pages of this handout are just solutions. What we're going to do next is come back and work homework problems 3, 6, 7, 9, and 10. Okay, so take a break and come back when you're ready.